Today we'll be covering the second topic in the ZIMSEC O-Level Maths syllabus, which is on sets. So to look at what the syllabus entails, it mostly looks, let me just get to the top of the page. So the syllabus mostly looks at looking at sets and sets notation in Form 1, and then understanding the different types of sets, and then continuing in Form 2 with Venn diagrams with 2 subsets. Then for O-Level, then expanding that to Venn diagram with 3 subsets. So a set is a collection of elements, and that can be anything like numbers, by letters. For example, if you had a word such as pen, the set of letters in that word would be P, L, A, N, and E. So that already makes a set. So it's a collection of elements. If it can be numbers, maybe yours a set of the first 3 odd numbers, right? Let's see, set of the first 3 odd numbers. So odd numbers, we know that they're those that are not divisible by, that are divisible by 2 and leave a remainder, right? So they're not divisible by 2 without leaving a remainder. So we're going to have 1, we're going to have 3, and we're going to have 5. And that's the first 3 odd numbers. To understand sets, we're going to be looking at what set notations there are, so the different words or descriptions that can be used, different annotations that can be used with sets. So the universal set is a set of everything. For example, if we're told that we have a universal set of numbers between 1 and 10, right? So what we then have is you usually have a rectangle to represent the universal set, and then you have your universal sign on outside. Then you have all the numbers. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So in this way, they are not showing any particular subsets, but it's just the overall universal set. So everything that falls within these boundaries counts as the contents of the sets. And then an empty set can also be called a null set, which means that it's a set with no elements, right? For example, if A, we're told that if A is a set of numbers of multiples of 5 less than 4, right? So when we look at it, let's just start by saying, what are the multiples of 5? So to start with, we're going to have 5 times 1, that's 5, times 2, that's 10, times 3, that's 15, times 4, that's 20, and we go on and on and on. When we look at this, right, they are all greater than 4. So all these numbers are greater than 4. So the set itself, there are no multiples of 5 that are less than 4. So it's a null set, right? Great. And then the next question, the next part says number of elements. So number of elements just says how many things are in the element, right? So how many components, so to say, are in the element. So let's say we have our universal set right here, and it has numbers 1, 5, 7, and 9. So how many elements are in there? That's going to be 1, 2, 3, 4. So the number of elements in the universal set is equal to 4. Then an element, so in this case, we saw that X is an element of, which means that X is part of that set, right? So that if we're then told to pick anything from that set, it's either going to be 1, 4, or 9, right? So for example, we have the universal set, and then we have a set in there, which we're going to call A, and inside that set, that's when we have the numbers 1, 4, and 9. Maybe outside we have 3, 7, and 8. So when we're told maybe to pick something from the element of A, we either pick 1, we pick 4, or we pick 9. So those are the elements that make up A. And then a subset is part of A, right? So for example, if we're told that A is contained in B, right? That's what this annotation means, right? For example, A is a subset of B. That means every element in A is also in B. So for example, if we're going to have an exam and we have a class of students, so the class is going to represent the universal set, and out of those students, they write an exam, right? So, okay, maybe the universal set, let's take the universal set to be, let's take the universal set to be the school. And then the class is going to be Y, right? And then we know that maybe X students pass the exam, right? So if 20% pass and 80% do not pass that particular exam, that means that X will always be in the class. So the number of students are always going to belong to that class, but it's fully contained in the class itself, although they're the only ones who pass the exam. So that's what it means to say A is a subset of B, or in this case, X is a subset of Y, and that everything in A is part of B, but not everything in B is part of A. And then a proper subset, e.g. A is a proper subset of B. This means that A is a subset of B, but it is not the same as B. That means A contains B. For example, if we have numbers 1, 2, 3, 6, they are contained in 1, 2, 3, 4, 6, 8, 12, and 24. So again, when we make our subset, so here we could have the biggest set, so we have our universal set, maybe we have B here, and then A. In A we have the numbers 1, 2, 3, and 6, and in B we have the rest of the numbers which are not going to show up in A. So that's going to be 4, 6, no sorry, we have 8, we have 6, 4, 8, 12, and 24. Okay, so then the intersection of A and B is where the two sets overlap, right? So this is where some of the elements in A are also in B. So then they are going to overlap. For example, we have a set A and we have a set B, right? For example, in a class, maybe you say how many students like apples. Let's say if A, let's say the universal set students in a class A, maybe they are students who play chess, and B are students who can swim. It is possible that there are students who can do both, who can play chess and who can swim. So that means that they'll fall in this boundary right here. And then here we will have Y and here we have Z, but we'll also have students who can't do anything. So Y are students who play chess but cannot swim. X are students who can do both, play chess and swim. Z are students who can swim but can't play chess. W are students who cannot do either play chess or swim. Then the union of A and B is everything in A and B. So in this case, it would be Y plus X plus Z, everything. That's what encompasses the union. And then the complement is the subset of elements that are not in that particular set. So for example, let me give an example. So usually, yes, I will just demonstrate what. Okay, so let's go back to the intersection. So the intersection, how it's usually represented is this part of the Venn diagram, the union. If we have a universal set and we have A and B, and if we have the same scenario where we have A and B and the universal set, union means everything that is covered in both sets. And then the complement, if we have A and if we have B, we have A and B and the universal set. A complement means everything that is not in A. So that's going to include everything outside and part of B as well, excluding the intersection because that's also in A. So that's how you represent it. So all these sketches that I was doing are what is called a Venn diagram. A Venn diagram illustrates the elements within sets, so elements within sets and any intersections. It consists of a rectangle representing the universal set and a circle for each set. So just a recap from Form 1 and Form 2. And the regions, for example, like I mentioned, you're going to have the complement, those are the regions not in A, then A intersection B, those are where they overlap, and then the union are where they are both. So just as a reminder. So we have this example. Write down, we have a Venn diagram with a universal set. We have A and B sets, and we have numbers in different sets. Write down the number of elements in A, right? That's what this means. Number of elements in set A. Okay, great. When we look at A, just listing down the elements that are in there, we have 2, we have 6, we have 12, we have 14, and we have 28. Now looking at how many doors are, we have 1, 2, 3, 4, 5. Therefore, number of elements in A is equal to 5. Then the next question said, use set notation to complete the sentence 14 and 28. When we look at 14 and 28, we realize that they are part of this, which is the intersection, right? So it means that the set containing 14 and 28 is A intersection B. It's the intersection of A and B. So that's the answer. Then part C says, write down the elements that are in the set A complement union B. So let's look at it. A complement, which means elements not in A but in the universal set. So going back, we're trying to look at elements not in A. We have 1, 5, 35, 21, 7, and 8. So we have 1, 5, 7, 8, 21, 35. You just need to go and confirm. So we have 1, 5, 7, 8, 35, 21. 1, 5, 7, 8, 21, 35. Okay, perfect. And then we need those in B. And in B, going back, so B, if we need to shed it just as a recap, B is everything in this part, right? So we have 7, 14, 21, 28, 35. So we have 7, 14, 21, 28, and 35, right? And now the question asks us, to find the union, which means numbers that are in both A complement and in B. So we have 1. So I'll just be I'll be cancelling to make sure that I don't repeat any numbers. So we have 1. And then we're going to have 5. And then we're going to have 7, which is in both A complement and in B. So we don't have to repeat it. We only mention it once. And then we have 8. And then we have 14. And then we have 21, which is also in both. So we do not want to repeat it. And then we have 28, only in B. And then lastly, we have 35. So those are the elements that are in that set. So for practice, you can try exercise 1, which talks about writing complements of different sets given a universal set. So yeah, you can take a screenshot, pause the video, and give it an attempt. If you need any help, be free to reach out and I can explain this further.